All right, hi everyone, welcome to today's SQL Office Hours session. We're going to be talking about something that actually a problem I encountered recently to do with speeding up the performance of Scalar subqueries. So what are Scalar subqueries? We're going to look at what Scalar subqueries are, why they're performance issues, and what we can do about them, and talk about a join type that I'm guessing a lot of you have never seen before, that is cross-apply. Right, so start off with, we can use Scalar subqueries, so selects in the selects to do things like this. And what I had is something like this. We've got our query, and then we were counting the rows from a child table. And when you got something like this, people then might want to see other aggregations in these totals as well. So at the moment, we're just counting the rows, but people may also want to throw in things like the average, and then they think a bit further and throw in the maximum and maybe the sum and other aggregations as well. So the easy way to do this is to just add more and more of these Scalar subqueries. But as we chuck more and more of these in, things get slower and slower, and eventually they could take a really long time. And the people who are asking for these changes are like, why is this so slow? Why is this taking so long? And as I said, this is something I was actually tuning myself a month or so ago now, and it relates to pages on DevGym. So one of them in particular is this classes page. So we can see we've got which classes. So these are free classes you can take on SQL and related topics on the DevGym, and there aren't many in the report here. So there's only actually 9 available classes, but we had these Scalar subqueries to calculate all the values in these things here. So things like what the average rating people had given to them, what percentage complete they were for classes that you'd taken, how many modules they were, and how many people had joined these classes as well. So that's what this little number here is too. So although we've only actually got 9 rows in the report, just scanning down the number of people who've taken these, you can see 32,000 there, 10,500 there, and so on. You can just by glancing at this tell that actually we're processing well over 50,000 rows to produce this report. So it looks quite simple, looks like not a lot of information, but under the covers, we are actually crunching up quite a bit of data. And it was actually quite a bit more than that as well for, kind of implementation reasons and so on and so forth. So this was something I was looking at, seeing how we could make it better. And I'll kind of walk through roughly what I did and, talk about pros and cons of various approaches. So back over to the slides. So hi everyone, I'm Chris Saxon. I'm part of Gerald Venzel's developer advocate team. It's my job to help you get the best out of Oracle database and hopefully have a little bit of fun whilst doing so. So as I say, today we're going to be looking at speeding up Scalar subqueries, or the performance of Scalar subqueries. And if you've got questions, please put them in the question answer window. I'll leave time for them as we go through this session. So first up, probably the most basic question or thing to cover is what exactly a Scalar subquery is. So hopefully most of you, at least I did, familiar with the concept of a subquery, but a Scalar subquery has a couple of special properties. So it's typically, we have them in the select clause. So in this case, we've got our parent query, and we're using that to look up how many matching rows there are in the children, so count how many rows there are. And a Scalar subquery is one that returns one column and at most one row. It could return 0 rows, but it's one column and one row, basically. And we usually see these in the select clause. We can easily chain these up, as we saw, to do things like count how many children there are or get the totals for them, and so on and so forth. But we can also use these Scalar subqueries in a whole bunch of other places as well. And a lot of the places, it's legal to use a SQL expression. So we could also put them in the where clause, you could put them in the order by, you could put them in the fetch first clause. there's quite a few places you can use scalar subqueries. There's a few you can't. Obvious things, some key restrictions are things like default values for columns in a table, check constraints or other constraints in the database cannot have scalar subqueries, but there is a lot of places we can use them. So I had this query with a whole bunch of scalar subqueries in them, that classes table page that we saw. And you might be going, well, why is that so bad? What's the problem? What's the big deal? Why was that so slow? So at this point, I'm going to jump into a demo to kind of show you why this can be an issue. So what I've got here is I've got basic table. It's got 1,000 rows in it, and I've got a couple of child tables for it. And each of those have got 100,000 rows. So these are pretty small tables in database terms, right? You know, anything under 1 million rows these days is pretty tiny for modern databases. And if we just fetch all the rows from the parent table, or less than 100, we can see that query is nice and fast. So I've got another query here with a whole bunch of scalar subqueries. I'm just going to set this going because it's going to take a little while. And while it runs, we'll just kind of talk through it. We can see we've got 4 scalar subqueries here, 1 against each of the child, or 2 against each of the child tables, as I should say, and calculating different aggregations. We've also got a little row num clause in there as well. There is a reason for that. I'll come back to exactly why that is later. But for now, the important thing is to note that took 12 seconds to execute. So we had a query which was like lightning quick, stuck in a whole bunch of scalar subqueries, and now it's taking well over 10 seconds, which is almost certainly too long for most pages. Certainly customer end-facing pages, that's just way too long. So why is that so slow? Well, to find out, I'm going to get the execution plan for it. So the runtime statistics for this query, so we can see how much work it's actually doing to process this. And as you can see, this is taking a little while to chunter away, and eventually it comes up. And if we bring it up and get rid of that, hide that, so we can see the plan in a bit more detail, first thing you'll notice is there is a whole bunch of full scans going on in here. So we see full scanning each of the tables. Now, some of you might go, well, why don't you just create some indexes to speed this query up, Chris? I mean, in a real production system, definitely would be some indexes, or at least I'd hope you'd have some indexes on these join criteria. I haven't done it in this instance just to help prove the point, just show that we need relatively small data sets to make things really slow. So why is it so slow? Well, the key thing to look at here is this last starts column. How many times did we do this thing? And you can now quite easily see why it's taking so long. We're doing each of these things 100 times. So we're doing 100 full table scans of child 1, and again for child 2, and again for child 1, and for child 2. Right? It's no wonder it's so slow, because we're doing 400 full table scans, which is, you know, close to 400 more than we really want to, right? We're doing a lot of work here, so no wonder it is so slow. And the problem is, for each value, each driving value from the parent query, so C1 here, we are having to run that query in the scalar subquery again. So we're getting 100 rows out of it, and for each of that 100 rows, we are then doing 4 full table scans, 2 against each of the 2 child tables. So a lot of work, and no wonder this is proving to be quite slow. So any questions or comments on that before we jump back over and talk a bit about what to do instead, or how to make this better? Okay then, so these scalar subqueries were very slow. You know, we were executing them once for each row we were getting from that driving table. So the question here is, well, what should I have done instead? How can we make this better and faster? How should I have rewritten this query? Well, one way to make this better is, instead of having a scalar subquery, so here I'm counting up the rows in the children, is we can take that query and actually join it to the parent query. So we'll remove that scalar subquery there, and then we will join it. Now, because the scalar subquery only executes for each row we get from the parent table, and there may be no matching rows in that scalar subquery, we have to outer join it. We can't just inner join it, at least in general, okay? For you're taking a scalar subquery, to be sure absolutely you get the same result, you need to outer join the table. Now, you may know based on your data that that subquery is always going to return at least one row, so you could make it an inner join, but to be general case functionally equivalent, you need to outer join it. And then of course we need to group the results as well. So and before I was getting one row from the parent table, and for each of those I was counting the rows in the children. I want to preserve that and just still only have one row from the parent table in my results. I don't want to have a row for each child in the results. So we need to group by all the columns in the select, all the columns that weren't part of the scalar subquery before, right? So that's kind of probably the ideal way to do this. Take that scalar subquery and turn it into join. So I could have done that, but let's just take a little look at the query I was trying to improve here. So this is a little snapshot of it. You can see this, it's a big query, and there's a lot of scalar subqueries I was trying to rewrite here. And I thought about this for a couple of minutes, and I was like, it's going to be a bit of a faff to join these in, to turn these into joins, particularly as I had lots of different tables that I was trying to access, or in some cases I was accessing the same table but different rows from them. So I had different where clauses, which made things even more complicated because it wasn't the same scalar subquery with different selecting a different thing. They were actually different queries themselves. So I had kind of something like this. I got a main query, that's the driving rows, and then there was multiple subqueries, each of which a one-to-many relationship. So that main query got multiple rows for like how many people actually took the course, multiple rows for how many reviews there were for the classes, that kind of thing. And the key thing here, because we got this one-to-many or multiple one-to-many, we just join everything up regularly, we actually end up with the cross product of the two scalar subqueries, right? So for each row in this one scalar subquery, we're going to end up joining it to each row from the other scalar subquery, unless there's some common join criteria. And there wasn't in this case, or at least there wasn't in every case. And that will often be the situation. You don't always have common join criteria between the two. So it's like, not only was it going to be a bit of a faff to join them, because it was kind of a complicated query anyway, I'd have to have multiple nestings. So for each scalar subquery, join it or outer join it to the query, group it and get the aggregation. And then outside that, have another join the next scalar subquery. So I couldn't just join everything normally and then group by at the end. I had to have nested levels of groupings. And I'll show again in a demo a bit later, show exactly why that's a problem and why you need to do this. So I was there kind of like pondering this a little bit and kind of going, turning these into joins is going to be a bit of a faff. I want something that's a bit more straightforward, a bit easier to include in, to convert these. And I thought about it for a moment and realized there is a join type, relatively new join type, which I could use instead. And that is a cross apply. And this is something, at this point, some of you kind of going, what's cross apply? I've not heard of that before. What is going on? So this is a relatively new join type. So this was added in Oracle Database 12c. So, I mean, it's been around 8 years now, but still in relative terms, it is much more recent than all the other ones, like just basic inner join and outer join, which have been here for 4 decades or so. So what is cross-apply and why did I need to use this? Well, this relates to a point that Goran's made. Goran said, why didn't I could have used an inline view. What cross-apply allows you to do is have an inline view, but join inside the inline view to the tables outside it. So we can have something like this. We've got my outer table or outer query, cross-apply we've got in our view, and we can join to that outer table within the cross-apply. This is something you can't do with a standard inline view. You cannot do the join inside there. So, particularly if this inner data set is huge, or we only want a fraction of it from the rows from the outer data set, then we don't necessarily want to process all that data. So cross-apply allows you to only process the rows from the inner data set that match a row from the outer data set. Okay, so that's hopefully giving you some idea to what cross-apply is. How can I use this to do the scalar subqueries? Well, let's say we've got our query here with 3 scalar subqueries in it: count, average, and max. The rest of these is all the same. So it's the same from clause, reading the same tables with the same where clause, joining them to the parent query. The only thing that is different about these scalar subqueries is they are doing different aggregations: count, average, or max. So we've got one of those for each thing. So what we can do is have our cross-applying clause and take those aggregations and put them within the cross-apply. So take one of those scalar subqueries, the from and where, and put all 3 of those aggregations into one cross-apply. So this means instead of computing this query 3 times for a row, we can compute it once. In one pass, we get all 3 of those totals rather than having to do it 3 times to get them all individually. So we can then replace those scalar subqueries with the values we get from our cross-apply inline view. So at this point, I'm going to jump back over to a demo and see if there's any questions or comments. So from Judith, what about doing an aggregate query on each of child T1 and T2 and joining these to T? I think we'll come back to that a little bit later because, well, that's kind of what I'm doing here with the cross-apply, Judith. So let's come back to that a bit later on, see if what I'm doing kind of answers the question for you. So Aditya, is it not similar to exist clause? Well, yes and no. Yes, in the sense that you can join within the subquery, but exists only checks if there is a matching row. We do not get the rows from the exist clause itself. With cross-apply, you return the rows returned by that subquery. So this is where I think the demo is really useful to walk through some examples. This will hopefully show why this can be useful and how it differs from other things that are around. Let me just pin that auto trace before I move on. So I've got my customer order schema. So this is a new sample schema I made a couple of years ago now. And what I want to do is find all the stores and the 3 most recent orders, the last 3 orders placed at each location. So what I can do is use the cross-apply to do that. So you can see I'm joining the orders on the store ID. So I'm joining the stores, the outer table, S, inside the subquery and doing a fetch first to get the last 3 orders. We'll run that and we can see we get for each store the 3 rows that we had before. To explain show why this is different to exists, if we just remove that and change that to an exists. So notice this is changing cross-apply to an exists. This just returns all the stores where there is a matching row from this subquery. Can we do that? Yeah, we can do that. We're not getting the 3 most recent orders from each store. We're just getting all the stores where there is an order in place. With cross apply, we are getting the actual rows from the subquery as well in the result set. Okay, so these are quite different things. We run that again, we'll see we get 3 rows for each one. Okay, so let's cross apply. Now there is a similar, or I say similar, another way of doing this, which some of you may have seen, and that is lateral. So this is in fact in Oracle database exactly the same thing. So we could write it as a cross apply, or we could write it as a lateral, and this works identically. So these are the same thing. I've used the comma syntax for joining them here. If you prefer like the fully qualified join syntax, we could also have cross join lateral. So these 3 queries are exactly the same thing. They get stores and the 3 most recent orders from each store. We can then also use this to kind of filter the outer table. So let's just find the stores that begin with M, so Madrid, Mexico, Mumbai, and we're then only actually going to look up orders for those 3 locations. We're going to run this subquery for those because we've got the join within here. So this is nice. This is returning us all the stores that have an order. Notice I'm saying stores that have an order. This is kind of like an inner join or an inner cross apply. I'm not sure that's quite correct syntax, but basically we're only going to get stores where this subquery has a matching row. To show case where that doesn't happen, let's put a filter inside the subquery. So I'm going to look for all the stores or the 3 most recent orders placed after this date for each store. Now, there are some stores which have no orders placed after this. And we notice our data set is a lot smaller now. Beijing has gone from our results. We're just going to Buenos Aires. So we only get rows from the stores table that have a matching row in this subquery. If we want to get all the stores, even if the subquery returns nothing, we need to make this an outer apply, so like an outer join. Just change cross to outer, and we will get those rows in the result set. So we get every store. So notice Beijing, there is no order details because there was no order placed on or after the 1st of April 2019. So cross apply will only return you rows from the outer table that have a matching row in the subquery. Outer apply will return you all the rows from the outer table along with any matching rows for the inner table. So see there's some comments at this point. So let's see. So Rob, what makes it so hard for the optimizer to reach many Scalar subquery to cross apply query? I'll come back to that, Rob. Like I say, there was a reason why I put rownum in that query at the start, which will probably help explain that. I will come back to that. Yeah, people saying select one, select null. You can select whatever you want in an exists clause. It's a good idea. Selecting null or selecting one shows that you're not really getting anything from the table, but actually you can select anything you want there. All right, any other comments or questions at this point? So we're all happy with cross apply, know what it means? Yes, no, maybe so. Okay, right, so let's go back and move on. Okay, so we saw that it was the original Scalar subquery. Oh, hang on. Let me step back a bit. I was going to go back to tuning across. Didn't finish my demo bit there. Okay, so we had my original Scalar subqueries, and I've turned those into cross applies. So we go back up here. Basically, I've taken these subqueries and those aggregations, and I put the aggregations within a cross apply and done the join there. So we run this, and it's not super quick, but we can already see it is a lot quicker than that original query. It's running in a couple of seconds rather than well over 10 seconds. And if we look at what's going on in the plan, we'll see why. Just pin that so we can save it for later reference should we want to. We can see we're now no longer doing 400 odd full table scans. So firstly, and perhaps most importantly, each of these child tables now only appears once in the query, right? So instead of like doubling up on our work, we're just reading them once and getting both of those aggregations in one pass, right? So already that should save us quite a bit. But also with the switch here, we have reduced how many times we can full scan one of these tables. So child 2, we can see, hopefully you can see, we've gone down to executing it just once, okay? So that is substantially reducing how much work we're doing, which make things a lot faster. We are, however, still got like 100 odd full scans of our child table here. So still not as fast as we could be. To do that, ideally, as I said, we could then turn everything into joins. Now, I said, we couldn't just join everything up. We have to do these nesting. So join and group child 1, and then join and group child 2. So we've got nested levels of subqueries. And we do that, and we'll see now, hopefully, yeah, nice and quick, half a second, we get the plan, and hopefully, again, we will see just one execution of each thing. So instead of hundreds and hundreds of full scans, we're down to now just one full scan per table. Much better, exactly what we want, a lot faster. And maybe we'll create some indexes here as well and improve import performance even further. Now, just to kind of prove the point about why we can't join everything up at the same level. So if we take a look here, I've added in a sum. So I've got a sum for child 2 of that column, and you can see there's like values around 5,000. If we just do everything as straight joins, we are going to multiply up the result for this sum. The rest of the rows, actually, it doesn't matter. Like min and max are not sensitive to that, at least in this scenario. But we've multiplied up all those sums by 100. Why? Well, for each row in T, in our parent table, there are 100 matching rows in child 1 and 100 matching rows in child 2. So we're multiplying everything up by a factor of 100 for these subqueries if you just join everything directly. You need to kind of nest your subqueries like this, have multiple levels of subqueries to get it correct. If you've got different things where you need to process it like that. And that's part of what made rewriting this query in the first place, that query I was showing you before, quite complicated, is I had several of these to do, and I would have had to have multiple levels of nesting. Okay, so I see there's some comments, questions. So Sven, is the main table still a key preserve table? In the sense, so in this example, Sven, so you mean are these primary or unique values from the parent table for the cross-apply? In this case, yes. In general, I don't think that's a restriction or requirement that's needed, but it is in this case, if that's what you're getting at. If it's not, please clarify, okay? Rajinder, what is the best approach to go with cross-apply? So, like I said, the reason I went with cross-apply here is I had quite a few of these. If we go back to my Scalar subqueries, I had several of these Scalar subqueries in my original parent thing, and a few of them all referenced, basically were the same except for what they were actually accessing, what they were aggregating. So this is going account distinct, that's doing a max of the same table. I had a similar thing. So I had multiple different aggregations I needed to calculate. And we can't do that within a Scalar subquery, right? We can't just extend them on here because by definition, it can have at most one column. So I do that, it's going to blow up and tell me there's a problem with my results here. By taking this and making it cross-apply, it meant I can reduce how many times we're referencing this table. So just generally in SQL, if you've got multiple subqueries which access the same rows from the same tables, it's time to pause and think to yourself, there's almost certainly a better way to rewrite this, because the database is going to have to process the same data twice, or however many times it appears in your query. By taking this and making it a cross-apply means we can only access this just once. We're ensure we're accessing or referencing child 1 just once in our query, minimizing how bad things can be. Okay. So other comments, Andrew Allen, it appears that cross-outer reply causes the optimizer to pre-execute the Scalar subquery for the join predicate, then provide the results to the outer query at join time. I'm not sure that's quite what is happening, because if we look, is this the cross-apply? No. So let me go down, rerun my cross-apply here. If we get the final flash, give it a second to come on. So the first table we access is still that parent table, the T table. So that is the driver for this. And then it is, for the rows we get from this, it is looking up the rows from the child table. So it's not running the child query and getting all the rows out of that, because there's actually more rows in all of these tables than is returned by the query, right? There's 1,000 rows in my parent table. All 1,000 of those rows have 100 matching rows in each of the child tables. We are not processing all of those rows for all of those tables. We're only getting the first 100 rows from T, and for those 100 rows, looking up the matching children within the cross-apply. So we're not pre-calculating the whole data set for these subqueries. We're only doing it for those rows from whatever the outer or driving query is. So hopefully that explains or clarifies things for you, Andrew. So Sven, clarification, if we use such a select inside a view, we can update the columns from the driving table of the view. When switching from Scalar subqueries, I think we lose this ability from Scalar subquery to cross. If we use such as, we can update the columns from the driving table. Oh, I see what you mean. So you mean talking about from an update perspective? That's a good question. I'd have to check that. Maybe we've got some time at the end. We can try it out. I don't know. Well, we can give it a try, maybe. I got you now there. Okay. Okay. Rajesh, maybe if we can join both projections and separate them using regular expression. So Rajesh, are you meaning doing something like this? Oh, come on, quote. Doing something like that, concatenate them all together. I mean, so yeah, I mean, yes, you could do something like that. I don't like doing things like that, okay? Because it just makes your code more complicated, harder to read. Particularly, I mean, when you're dealing with numbers, it can be fairly safe to kind of have things like hashes in between, but with text, it's really difficult to be absolutely certain that whatever you're using as your separator here is not in the data set, and you're not going to get incorrect matches. It's just messy. I don't like it. I mean, you could try and do that, but yeah, I think there's better ways to do this kind of thing than trying to do something like that. If that's not what you meant, Rajesh, then please if you could do a very quick example to clarify, that would help. So Roman, what about the scenario where all Scalar subqueries are going over different tables, like from table 1, table 2, table 3? So I mean, that's a good point. They could be all different tables. So bear that in mind, Roman. We'll kind of come back to that, because there's a few other things I want to talk about first. which might help kind of explain or clarify that. Alrighty then. So as we see in this case, so we started out with a query which took well over 10 seconds with those Scalar subqueries, converted it to cross-apply, and it took a couple of seconds. I mean, it was significantly faster, not as fast as if we just joined everything together, but as I said, there are further optimizations we could have made. And in my example, in the real query I was doing, it was good. That change in itself was good enough, at least at that point, to process it. So at this point, some of you are probably going like, right, so this is looking bad news for Scalar subqueries. Like, why would we ever write a Scalar subquery? Are you just telling us never ever to do this? Well, okay, as always, there's trade-offs, and there's some scenarios where some features are actually the better or faster way to do things, even if in general they can come out worse. So what I've been doing so far is I've got a parent table or a parent query and looking at child rows. So each row that drives the Scalar subquery, or each value, is unique. So we've got key values from T, parent table, and each of those primary unique values, we're doing a lookup in the child table. So each Scalar subquery has a different driving value. Let's flip that around, right? Let's instead have the driving query be the child table and our Scalar subquery be the parent table. So let's imagine we're doing things like lookup tables. So things like status, codes, countries, currencies, that kind of thing. We've got each of those from our child table, and we've got a Scalar subquery looking up the parent row. So these tables they're fairly small. Status codes, quite often there might only be 5 to 10 rows in the entire table. Countries and currencies, okay, there's a couple of hundred rows in the table in total, but odds are that for your particular query, there's only actually a handful of different values. If you're doing currency, looking at the names of currencies for invoices for your business, chances are 90% of the rows are covered by 2 or 3 different currencies, maybe 5 at most. You might have a long tail of a whole bunch of different ones, but the majority of rows will just use a few different currencies for a lot of businesses. So we are using the same value to do a lookup for many rows. So we've got something like this. We've got our outer query, which is the child table, and we are looking at rows in the parent table, doing a description lookup or something like that. As I said, key thing here is lots of rows have the same value as the driving value for the Scalar subquery. Well, when we do this, the database is able to do something very neat. It's something called Scalar subquery caching. It's able to go, okay, let's say I'm doing currency conversions. Got a row with GBP, British pounds, looking up the name of that. So that row is GBP, next row is GBP. Well, instead of re-executing that query against the currencies lookup table, I can reuse the value I've already calculated, right? And this can significantly reduce how many times we actually run that Scalar subquery. So at this point, I'm going to jump back to some more demos to show kind of how it actually works. All right, so let me scroll down, go back past all my cross-apply stuff. Okay, let's see. So before we do that, I said there was a reason why I stuck row num in that original query. So here you can see same query we had at the start, except I've removed row num. Execute that, and we will find that hopefully, substantially quicker. It only takes a couple of seconds. And if we look at the plan, the database has no longer run each Scalar subquery hundreds of times. It has in fact converted most of them into joins, right? It has done what I discussed doing up here manually. So in some cases, the optimizer is already able to kind of do this nice transformation for you and make these Scalar subqueries faster. Not in all cases. There are things like row num and other things you can put in which prevent this optimization from happening. So this is maybe why you've not noticed this problem, or if you have noticed it's not been quite as drastically bad as I've made it out to be, is because a lot of the time the database is able to resolve this for you. Okay, so instead of having like 400 odd full table scans, we've actually just got 100 full table scans of one of the children. So Roman, your point about if they're different tables in those subqueries, there's actually a good chance that the optimizer has done this for you already. It's not guaranteed. There are things that can block this from happening, Ronan being one of them, but it might already happen. Okay, so it's, if you've gone like, why have I've used Scalar subqueries and it's all been fine, what are you going on about, Chris? This is potentially one of the reasons. The optimizer has already converted them into joins for you. Now, there's still benefits if we've got the same table many times. You can still see that child 1, child 1, child 2, child 2. There is still benefits from converting that to cross-apply or other type, or manually doing the join, because we read the table once instead of multiple times. So there's still benefits to changing the query in this example, but if they're all separate subqueries, it may not be too bad. So I hope that answers your question, Roman, or at least makes things a bit clearer. All right, so that's one thing. The database is already able to optimize this, but it can also do Scalar subquery caching. So here I've flipped it around. Let's just run the query and see it's pretty quick. We're processing 1,000 rows. So for each parent value, there are 100 rows in the child, so we get 1,000 rows in the output. If we look at the execution plan and we bring that up, we can see that Scalar, that full scan of T flash starts 10. We got 1,000 rows in our output, but we only executed the Scalar subquery 10 times. Why? Well, because there is only 10 different values that we are passing into that Scalar subquery. You know, we're passing this value C1 into it. There's only 10 of those. So the database is able to save the result of it and not execute it 1,000 times. So this can be a big saving. And in some cases, this can actually be substantially quicker than doing a join or any of the other things I've talked about. So now, actually, finally at last, I'll create an index because it helps demonstrate the point a bit better here. So I've got a slightly funky looking query here. So I'm getting rows from the child, and for every 10th one, I'm running this Scalar subquery. So we'll just run the query to get the results, and you can see we're only getting a value for that for every 10th row. The other thing to note here is that all the rows have the same value for C2. So in this thing, it is in effect a constant. Everything we look up for this uses that same value. So the database, instead of running it 200 odd times, can run it just once. And if we get the plan for that, we can see it's also able to do this lovely optimization, a min-max scan of the index, which is super efficient because it knows it's going to get just one. And that is very, very efficient. So we've full scanned the child here, got no index, but we've just done one lookup of the index for this Scalar subquery, right? And this is very efficient. This is actually, for this particular crazy thing that I'm doing here, is actually better than a join. If we turn this into a join and do that filtering, slightly wacky filtering in the join here, let's just pin that so we can save it. In this case, the optimizer full scans the index for my child here, rather than doing that very efficient one row min-max lookup of it. So it's actually more work, right? In this example, the join, the Scalar subquery, because we can do this nice fast thing just once instead of doing it many times or full scanning the index or table. It is actually the fastest and best way to do it in this scenario. Now, at this point, you kind of like this case stuff. That all looks a bit contrived and crazy, Chris. You know, what's going on with that? Well, there's two kind of reasons I've done this. First up, I've actually seen people do something like this fairly regularly. Now, okay, it's not like mod Ronum, but it's like case when date is greater than the sysdate or something like that. So the scalar subquery is conditional. And in some cases, I've actually seen people have chained multiple of these together. So there's 2 or 3 different scalar subqueries, and there's a case expression to choose between them as appropriate. So I've seen people do that. It's not super common, but I have seen that happen. So that's one reason. This is something that does crop up from every now and again. The other reason to kind of demonstrate this is without that case expression, well, what does the optimizer do? It does that join conversion that I was discussing earlier. It converts the scalar subquery into a join, and is actually worse than what we had before. So, this case expression blocks that conversion, which also helps demonstrate the point, but also is actually faster in this scenario. Okie dokie. I see. So someone's all right. So please do put your comments in the question and answer window rather than chat. Okay. All right. So Sven, there are also other optimization issues to consider. There we go. If the main query already joins many tables, then the number of possible execution plans becomes very large. Yep. So there's around 6, 7 tables when the optimizer will stop considering all the possible permutations. I'll have to check that, but yeah, you're right. The more tables you join, the complexity goes up factorially, right? So it grows very quickly. Moving a table to a scalar subquery can, in such case, improve performance because it reduces hard pass time, opens up execution plans that CBO didn't consider because max optimized permutations was really reached. I guess there was something else you wanted to say there, Sven. So, this is one of the things to kind of get across here is like there are many different ways of writing a query in SQL, and that's like the great promise of SQL is that you can write a query in any way you want, and the optimizer will figure out the best way to do it, and it doesn't matter as long as it's functionally equivalent to what you want. It shouldn't matter, and a lot of the times it doesn't, but in practice it does, right? And this is one of those situations where it really can affect things. So Joseph. Last time I looked into tuning in clause containing collections years ago with 12C. The two common techniques for preventing optimizer from using a default subquery cardinality of 8,000 were use the undocumented cardinality hint, or use Ronum greater than 0 to materialize the subquery. Are these still required with the latest versions of Oracle? Are there any newer techniques? So the optimizer has gotten better at estimating the cardinality of table collections, Joseph. In terms of, there are multiple ways to kind of do this kind of thing. If you've got the with clause, so with something like this, you can have the materialize hint. It's semi-documented. It's not in the actual official docs, but it appears all sorts of over places all over the shop. So you could do something like this, and it will save the result set. So rather than using Ronum greater than 0 to materialize, it's possible the with clause. You can force the with clause to materialize like this. And in some cases, the database will materialize it. In terms of other solutions, nothing comes to mind immediately, but excuse me. Yeah, that's an area where there's challenges, shall we say, right? So Kevin, what is a general principle you can recommend when writing subquery? seems sometimes databases smart out, figure out the best execution plan. Sometimes we have to write a good query. Yes, that's kind of the point here, Kevin. I'm going to recap these points at the end to kind of give my thoughts and advice. So we'll come to that, and let me know if you've still got some questions once I've done that. So there was one final thing I wanted to cover off in the demo. So I've got a function here. It's a bit of a noddy, very dumb function. It just sleeps for 1 second and returns the input value. And I'm going to use this in the where clause, right? We've got 5 rows, and so we're going to execute it for all 5 rows. So it's going to take 5 seconds to actually execute it. Dum-de-dum-de-dum. There we go, right? Because it's having to evaluate it for each row. Thing is, however, the value, our input value here, y, is a constant. So it's the same for every single row. So we can actually use this scalar subquery trick to say scalar subquery caching to avoid executing it 5 times. By doing this, by putting it in there, the database now only actually executes that function once. You can see we returned in a second rather than 5 seconds. So this is another reason you might want to use scalar subqueries. If you've got function calls in your where clause, and there is lots of rows have the same input values for them, putting it in a scalar subqueries can reduce how many times you actually execute it. Now, obviously, in the in the real world, you don't do crazy things like put sleeps in your functions. And of course, the correct ideal solution is to not have the function at all in your where clause, just strip all the logic out and do it in pure SQL. But that's one of those easier said than done things, right? Often in practice, there's something complicated that goes on in there, and it's just going to be a lot of work to refactor it into the SQL statement. So if you've got functions in your where clause and they're slow, and particularly if you cannot index them, so they're non-deterministic, for example, anything based on sysdate is a good example, and lots of rows have the same input values for those, sticking it in a scalar subquery is a little hack which can help you in some scenarios. Okay, alrighty then. So we're getting close to the hour. So a couple of things to recap, and then we can stick around and have some more questions should you want to. Alrighty then. So one thing to note here: if the database is not able to convert the scalar subquery into a join, so it's having to execute it, it can use scalar subquery caching to save the values. So how much work it does and how effective it is depends on how many lookup values there are. So if every row from your result set has the same value for that scalar subquery, it's constant in that result set, then a scalar subquery can be really fast because the database can execute it just once and cache the results and reuse them for all the other rows. And in this case, it can actually be the fastest way to write your query. We go to the other extreme where every value is unique for that scalar subquery. So each row from the input looks up a different row in that scalar subquery. Then we could end up executing it many times, and it can be really, really slow. So we can end up with lots of different values in there. So as I said, this is one of the areas where kind of the promise of SQL falls down a bit, that you can write any query you want and it will just work, and it will always be as fast as we can get it, at least as things stand today. And the big drawback with scalar subqueries is that performance range is huge, right? In the ideal scenario, everything's hunky-dory, it's all nice and fast. In the worst case is truly horrendous, potentially, for scalar subqueries. We're executing it full scans or whatever, an expensive subquery, once for every row that the query returns. That can be quite painful. And this is also something that can then confuse people new to SQL and so on. It's like, well, I used scalar subqueries here and it was perfectly fine, and now I'm using it here and everything just falls apart. And why? I don't understand. And it's really to do with how many different values you've got driving that scalar subquery, and whether or not the database is able to convert that into a join. So instead of using scalar subqueries, if you can convert them into joins and then group if necessary as appropriate, that is usually going to be the fastest method, or it's probably the most consistent method of the ones we're going to look at here. Obviously, joins have their own issues as well, but the swing between best and worst case tends not to be quite so bad. And also, we can avoid accessing the same table, referencing the same table many times in one query. Right? That's probably one of the big drawbacks for scalar subqueries. You've got lots of them and they're reading the same table, or you're probably reading the same rows many times, whether you've got scalar subquery caching going on or not, right? Generally not ideal. Lots of the time, the database is able to convert this into a join, but there are some things which prevent that. If you are in those situations, or you've got lots of scalar subqueries which you need to refactor, cross-apply is one technique you can use to get around this. And the reason I opted for it in this scenario is it was just much easier to do. Right, I had a massive query, lots of things to refactor to joins, and it was just far easier to take those scalar subqueries, turn them into cross-applies, and get the results. I didn't really need to restructure the query in any meaningful way other than doing that. So it is much easier to do in this scenario. Again, which do you want to use? The question you really need to be asking yourself here is, for that scalar subquery, how many different values do I expect it to have to process? So if you're going from a parent to a child, so each row from the driving query is unique, or each value from the driving query is unique for that scalar subquery, start to get worried, right? Things could get really bad. On the other hand, if multiple rows have the same value, scalar subqueries can be all right, can be good. And again, for this thing, generally, you just got to try things out. Try it out, check the plan, see how it works, and just review and monitor and stay on top of it. If you want to know more, as always, here's some links for you to see. I've got all the scripts from this session, so if you want to play with them and run around and see how it all works, follow that live SQL link. The case study I've got from Jonathan Lewis is because it's shortly after I did this, I took some scalar subqueries, converted them to cross-apply. He posted his post, which kind of did the opposite. He had some cross-applies, they were actually lateral joins, I think, and converted them into scalar subqueries, and that was the right solution in that scenario. So that's probably worth reading through to kind of follow his thought process and see why it worked in that scenario versus not in my scenario. Alrighty then, we're on the hour. If anyone's got any other comments or suggestions, I'm happy to hang around for a few more minutes and discuss them. If not, thanks for joining me. As always, I hope you enjoy this, but more importantly, I hope you learn something, stay safe, and hopefully we'll be actually able to see each other in person sometime in the maybe not too distant future. We'll see. All right, goodbye.